Okay, so for today's lesson, we are going to do a quick overview of heat and temperature. And to start, I just want everyone to visualize heat transfer through conductors and insulators. So I have a bunch of different materials here that we're going to group together into either conductors or insulators. And we'll look at why as well. So the materials I have are water, rubber, aluminum, wood, copper, paper clip, and paper. Okay, so I'm going to start with wood. I think that wood is an insulator because it has a lot of air pockets within the cell structure, so heat cannot transfer as well through wood, and it holds onto its heat a lot easier because of the air within the cellular structure of wood. Next, I'm going to do paper clip. So with paper clip, it's made out of metal. So metal usually has close packing of metal ions, which help carry its kinetic energy a lot more efficiently, which makes it a really good conductor. Now I'm going to do aluminum. So aluminum is made out of metal, and it actually absorbs heat quickly. So if you've ever cooked with aluminum in an oven, you may notice that when you take the foil out of the oven, it doesn't stay hot for that long because it is metal and it absorbs that heat very quickly. Next, we're going to do copper. We're going to say water because that's a bit of a tricky one. So once again, copper is made out of metal, and that means it doesn't hold on to its heat properties, its kinetic and thermal energy as efficiently. Now we're going to do rubber. So rubber has electrons and thermal energy that aren't free to move because of the nature of its materials, and it's a lot of dense matter, which means the atoms are closer together. And so since rubber is less dense, it holds on to heat easier. And then we're going to do paper. So once again, paper, it, like wood, has a lot of air structures within it because it's made from wood. So with water, it can kind of fit into both conductors or insulators. When we were talking about pure water, it has no dissolved ions, and therefore it's an insulator. As a fluid, a lot of heat isn't able to freely move through it, and it holds on to its properties a lot easier. But when we are talking about tap water, it has a lot of dissolved ions, and so since the dissolved ions are present within tap water and unpure water, then heat is not as able to move through water. Next, we're going to transition into making a little semantic map to talk about heat and temperature. So you guys can just draw along with me. And the 5 main focuses that we're going to focus on for the semantic map are heat, temperature, society, technology, and the environment. So we were talking about heat and heat transfer last class here. So I'm just going to write that really quickly here. Give you a minute to think about this, but does anyone remember what the 3 main types of heat transfer are? Yeah, so they are conduction, convection, and radiation. And thinking about heat in terms of society, the societal impact of heat might be thinking about how much hot water we use when we shower. And directly relating that back to heat transfer. So when the hot water touches your body, what kind of heat transfer is that? Yeah, so it is when it is conduction because it is directly touching your skin. So I'm just going to jot this down really quickly for societal impacts. So that's the main overview of today's lesson on heat and heat transfer and how it affects us. And next lesson we are going to talk about the technologies that we derived from heat as well as how heat affects our environment.